Assalamu alaikum. My name is Sahar Farooq. Today I'm going to represent transitive group. So let us discuss. First of all, we will discuss the topic. If we are going to discuss transitive action, intransitive action, regular action, and our theorem related to these topics. Transitive action and intransitive action. First of all, I would like to discuss what is a transitive action and intransitive action. Action of a group G on a set A is called transitive when the set is non-empty and there is exactly one orbit. From the definition, it is clear that if a finite permutation group G on a set A has only one orbit, then this action of a group is known as the transitive. For example, for n greater than or equal to 1, the usual action of Sn on the set 1 tends to n is transitive since there is a permutation sending 1 to every other element. An action of a group G on a set A is called intransitive when the set is non-empty and there is at least two orbits. For example, S3 is an intransitive group, Z3 is intransitive group in S4 because all of these S3 and Z3 have more than one orbit. Transitive group. An action of a group G on a set X is called transitive if it has a single orbit. That means for any two elements X and Y belonging to the set X, there exists G belonging to the permutation group G such that Y is equals to G dot X. It means that for every, if there is a relation between two elements belonging to the set XA, then this action of a group is known as the transitive. Theorem, a transitive permutation group G on a set A is regular if and only if for any two elements X, Y belonging to A, there is one and only one element of G which takes to Y. For example, we have a permutation group G and a set A. If you find one permutation, one orbit G, this is also equal to the set A. It means that if there is a one-to-one correspondence between the permutation group and the set A, then the transitive permutation group on a set A is regular. If and only if there is if every two elements X, Y belonging to A, there is a only one element. If G is finite permutation group and G is transitive, then the order of G is divisible by its degree. It means that as G is permutation group and G is transitive, a transitive means there is a relation between every two element X and Y belonging to the set X, then the order of G is divisible by its degree. Let us suppose that we have a set A who have a number of elements n, and it is also the orbit of G, and the degree of the G is also n. So by the corollary, it is clear that order of the G is divisible by its degree. The alternating group A and transitively on a set A to n for n greater than 2, and in fact it acts n minus 2 transitively for all n greater than or equal to 2. Example number 3, we have a set G permutation group and a set A. If we have to find out the one orbit G which is also equal to the set A, is also equal to the set A. Regular and half transitive. What are the regular transitive group and half transitive group? A permutation group G on a set A is said to be regular if G G tends to X is equals to E, where E is an identity subgroup for all X belonging to A. It means that if all the if we are if all the if we have to find out the orbits of a G which are equal to the identity element, then this permutation group on a set is said to be regular. A permutation group G on a set A is said to be half transitive if all orbits of G have the same number of elements. It means that if G if a permutation group G on a set A is said to be half transitive if all the orbits of G have the if we have to find out all the orbits of G and they have the same number of the elements, then this permutation group on a set A is said to be the half transitive. A transitive group, a permutation group on a set A is said to be K transitive if for any pair of K tuples, tuples mean we have two sets from x1 to xn and y1 tends to yn. There is an element z of G such that x iota z this is equal to y iota y iota and iota lies one less than and equal to I and which is less than equal to K. I think so. It is very clear to you. Thank you for listening my lecture. Thank you so much.